kind of deep, Josh. Isn't the future just the past? It's kind of deep. All right, we're gonna do. I'm really getting quiz today. Day 6 of class. All right, I trust. Day 6. We're gonna be the AAHL2. We're gonna be sticking around at 5.6. We're going to be covering chain rule. Chain rule is one of those things that, as of right now, you probably feel like, oh, I know how to do like so many derivatives, and like I could take the derivative of anything. And then you kind of see the chain rule, and you're like, actually, I didn't really know how to do the derivative of anything. And so the chain rule is anytime you have the derivative of a function within a function, a derivative of something within something else. So, for example, if we have something like y equals square root x, we absolutely know how to do that. In fact, we should memorize it. We should know that y prime is equal to 1 over 2 square root x. But as soon as we put something inside this, now all of a sudden, okay, actually I don't know how that should work, okay? And we could probably, guess, well, this part is probably still the same, the 1 over 2 square root x part. But there's got to be something more to it. Of course, we've got all this inside stuff. The chain rule is not really all that bad. It's very similar to the product and the quotient rule. And now you just have to be a little bit careful. The chain rule, I guess we'll get right into it. If f of x is equal to g of h of x, so that's g with the h on the inside of the g, f prime of x is going to be, you're going to take the derivative of g just like normal, and you're going to leave that h in there. You're not going to deal with the h. You're not going to worry about the h. So for example, for this question, you would just be ignoring x squared plus 5x plus 2. But of course, that has to come up somewhere. And basically, you're just going to tack it on to the end times h prime of x. So when you take the derivative of a function inside of a function, you just ignore the inside, take the derivative like normal, and then you go back, derivative of that inside, and you just tack that on with a little multiplication. So a question like this, again, it's different, but it doesn't end up actually being all that bad. We kind of just assume that all of this in here, just for now, let's just assume it's an x. So just like we did before, that would be y prime is equal to 1 over 2 square root x. But, it's not an x. It's actually all of this. So it goes right back in there. So you just, even though the inside is complicated, you don't worry about it, you don't mess with it, you don't deal with it. Then we've taken the derivative of the big function and ignored the inside. Now we have to go back and kind of add on that inside function. So let me reorganize it just a little bit. So now we're going to go back and we're going to multiply by whatever the derivative of that interior function is. Since it's, well, I've just been dragging it around, which is weird. X squared plus 5x plus 2, that's an easy derivative. 2x plus 5. And just like usual, you have to just kind of get a sense for how far should you continue to make this look a little bit nicer. A lot of the times, for a question like this, where we have a fraction piece and then times just a regular piece, we should try to put this piece on top of the fraction, because that's a totally fine place for it to go, and that will make it look much nicer. So as much as I've been chopping and moving stuff around, which is definitely strange, I guess I should at least have it written here with the original question on there somewhere. That is a pretty solid.
Can you pull out an x and then just simplify 2x?
Are you talking about from this? You cannot do that because these pluses have linked all of that together. The only way you could do that is if you could factor this into like two perfect squares, like difference of squares. Basically, no. And if you could do that here, you could have done it up here because this square root is the same as that square root. So there's no reason to kind of look into that square root later on. So let's power through a couple chain rules real quick because just like the rest of it, this is just something that we really want to work on. So f of x is equal to x squared minus 2x squared. So hopefully you can look at this, you can identify that there is a function on the inside and there's a bigger function being done to that whole thing. F prime of x is equal to, just ignore the inside. Think of it almost like it's just a plain old x squared. You're going to put the 2 in front. You're going to subtract 1 from the 2. That's all you're going to do. So we're going to have 2 parentheses, leave this alone. Then we've got to go back and now look at the inside and take the derivative of that inside, which would be 2x minus 2. Now for a question like this, we should be foiling this, and we should be getting all the way to the end, making this look a lot nicer. So f prime of x is going to be, if we foil this, I can just put this 2 in there really quick. That would be 2x squared minus 4x. Now we can foil it, and we get 4x cubed. And let's do this one next, minus 8x squared. And then let's do this one, minus 4x squared. What have I done? We did this and this. Then we did this and that. All right, let's go back. Early morning, foiling. Got it. Let's do, I guess these are both going to be the same. Minus 4x squared, and that's going to be minus 8x squared, and then that's going to be plus 8x. I don't know that I actually made a mistake. I just got a little twisted up. 4x cubed minus 12x squared plus 8x. Cool. Now a question like this is also a question that we could have solved before the chain rule if I locked you guys in this room and said figure it out, or else you're never allowed to leave. Because this original is something that you could get back into a manageable state, right? So you could foil this original first and then try to just do a power rule derivative. So if we foiled it, that would be, let me try foiling in my head again for the second time today. That would be negative 2x cubed and another negative 2x cubed, negative 4x cubed, and then that would be positive 4x squared. And then you could take the derivative, 4x cubed minus 12x squared plus 8x. Same thing we got? Nice. So that's a question that technically, instead of using our new chain rule, we could have just gone for our old school, foil it, and then derivative it. You want to be on the lookout for those. It is, especially on this first night, you want to be practicing chain rule where you can. And on a question like this, I would recommend, okay, like let's just do the chain rule to practice it. However, there could be a question on a quiz or a test where, oh my God, the chain rule is such a nightmare. And you get stuck in this endless simplification kind of thing where, you know what, maybe if I do 1 minute of little foiling, I'll be able to get there, get to the end. Now, if it's not a polynomial like that, it may just look like, let's see, let's do w of x, I guess. We're switching it up. I guess we already kind of went through an example like this, so I'll let you guys knock this one out. This should almost be so easy you can do it in your head. Anybody got the answer?
I got 3 over 2 root 3x minus 2.
Yep. Not too bad, right? The typical derivative that we've memorized is 1 over 2 root, and then that inside part just stays there, but then it just kind of ejects its own derivative, which is a 3, and we might as well write that on top. Nice. Good job. Let's do v of x is equal to sine of 3x cubed minus 2x. How do we feel about that answer? The derivative of sine is cosine. Leave the mess alone, and then it will just eject its own derivative. We good? Cool. One more. What if we had z of x is equal to cosine of sine of x? So I do want to point out that this is a sine inside of a cosine. It is not a product rule. If it looked like cosine x sine x, this is a product rule. It is a cosine of x and a sine of x. That's just a normal little product. But this one, of course, is a cosine of sine, which is its own little function there. See if you guys can work that one out. But it should only take you maybe 30 seconds. Anybody got the derivative of cosine of sine of x? Negative sine of sine of x. I agree with you. And cosine of x. Because we have to eject that inside derivative of sine. So that's a sine of sine times cosine. Now that's a little bit silly. Now we are going to do some more questions, but I do just want to really quick, if we bring this all back to our original f of x, and we just think about f of x equals square root of x, super basic. Isn't this like a function inside of a function? Isn't this, I mean, it's a very simple one. It's just a plain old x, but isn't that a thing inside of another thing? So how come we haven't been doing chain rule the whole time? Exactly, because this still does eject its own derivative, but the problem, or the, maybe not the problem, but the benefit is that when we kick out that derivative, it's just a 1, so who cares, right? So f prime of x, if you wanted to be some weirdo, you could like, you know, say, oh, the derivative of the inside, and like, right, nobody does that. But just wanted to kind of bring it all back. That's why we've been allowed to just ignore this until now, because we've just been dealing with a whole bunch of derivatives of 1. Even that, all these questions that we've been doing really aren't that bad, Okay, it requires you to take a pretty easy derivative, most of them we've memorized, and then to eject out another pretty easy derivative, which also we've either memorized or it's just a polynomial, so very easy. So where this is going to culminate, where this is all going to show up together, is now we're going to incorporate questions that have product, quotient, chain, like 2 of those 3. And then it's going to start getting really kind of messy. So let's say we've got 5x squared minus 1 power 4, 2x minus 9. So looking at this is some, binomial. We have the first binomial 4 different times, and we have the second binomial only once. And this is something that we could foil this, but we do not want to foil this, right? That would be foiling this together 4 separate times and then foiling another 2x minus 9 on top of there. This would be a ton of x's and a ton of combined like terms, and this would be awful to handle the algebra way. I mean, absolutely awful to handle the algebra way. We could do it, awful. Now, if we want to go ahead and do the derivative, I think we talked last time about dy dx. Yeah, I'm gonna do my best to throw that in to you a little bit. I think it's on the homework tonight. It just means derivative, don't stress about dy dx. We want to think about this as 2 things kind of at the same time. How in your head are you picturing this piece so that we can attack it with a derivative? Does it look like the power rule, the product rule, the quotient rule, the chain rule? I heard chain, I heard product, and you're both right. Because what I'm seeing here is that we have, if we call this F and we call this G, those 2 things are being producted, they're being multiplied together. We have to use a product rule, but also this F kind of has like a little H in there because it's got an interesting inside within that little. So we're going to have to do the product rule, multiply F times G, using the product rule, blah, 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 derivative 1, keep the other one the same, derivative the other, keep the one the same. But then whenever we take the derivative of this function, we're going to have to use the product rule. So whenever we go for the derivative there, we're going to have to use, I said product, but I think I meant chain. Okay, let's get into it. Product rule, I like to take the derivative of the first. That's just how I like to start. So let's go for this. The derivative of this piece should be 4 parentheses, 5x squared minus 1. The 4 drops down to a 3. And chain rule, eject 10x. Now that is just the derivative of this first piece. The way the product rule works is if we take the derivative of the first, we have to just multiply that with the plain original version of the second. Now the second half is going to be not as crazy because we're not going to need to do a chain rule when we go for the derivative of g. We're just going to be able to do a plain old derivative of g. So the second half shouldn't be too bad. The second half is going to be the plain old f, 5x squared minus 1 power 4. We did not take a derivative, so we're not doing a chain rule. We're not doing any ejecting of anything. And then the derivative of the second, which is super easy, just the 2. So before we go on, I want to make sure that I label this, here is f prime, a regular old g. Here is a regular old f. Here is g prime. And then this This is h prime that got ejected from the inside when we did our f prime. Okay. Now, this is the derivative. If we wanted to find out what is the slope or the gradient of the function at any x value, we could use this. If I said, what is the gradient at an x value of 0, we could plug in a 0, and we could figure it out. It would work. But this also is a pretty ugly thing that we're looking at here. And again, we could, but I mean, God, if we're gonna deal with, I mean, that x cubed thing there, even that alone, that's a 2-minuter just for us to spread it out into a cubic, which, I mean, it wouldn't quite be like a cubic, it would be even more, but then we also have this, which is just 4 of them stacked up, and so if we're gonna do that side, we might as well do that side, which is also awful. The thing to look out for when you do these product rule is you're gonna end up with some stuff on the left and some stuff on the right, and they're all kind of made of the same stuff, which means they're gonna have a lot of similarities between the left side and the right side, which means if you need to simplify beyond this, if you need this to look a little bit nicer, maybe the instructions tell you, sometimes you'll see a question that will say, prove that the derivative of y is blank, which basically means make sure you get far enough to match up your derivative to the derivative they've already given you. The way that you can handle this is look for GCF. So look about the left side and the right side of this product rule and see how much stuff can we just kind of GCF and pull out and pull away from this. And a lot of times there's quite a lot of similarities. So what do these two terms have in common? They both have a 2, right? There's a 2 right here, and there's a 4 we could take a 2 away from, or a 10 that we could take a 2 away from, but only one of them. Remember, this is kind of like 40. And so, yeah, we can, whoa. Yeah, we can take a 2 out from both of those. What else do they have in common? 5x squared minus 1, right? Over here, 5x squared minus 1, there's 3 total. And over here, 5x squared minus 1, there's 4 total. So we can afford to say they both have 3. And so, using GCF and undistributing, taking those pieces away from both halves, that means 5x squared minus 1 cubed and a 2 is what we can take away from both, leave behind so from this first one, we took away all of this. We made this 40 into a 20x. We still have 2x minus 9. Over here, this 2 is gone. 3 of these is gone. So we have a plus 5x squared minus 1, and that's it. And in there, that is looking like a 30-second, you know, we can nicen that up a lot. We don't have any big exponents. We don't have anything that's cubed that's going to cause a real nightmare. So 2 times 5x squared minus 1 cubed, parentheses, 20x times 2x is going to be 40x squared, and there's already a 5x squared, so I'm going to go for 45x squared. 20x times negative 9 is going to be negative 180x, and that's the only x term. And then minus 1. Now again, if you want to use the derivative to find a gradient value, what we have here is a legitimate derivative that will work just fine. However, down here, this one looks better. Now, another question, and we're not going to do it today, but you guys are capable of doing it, is imagine that the question said, find me the second derivative of this function. That is another time where you probably want to make that first derivative look a little bit nicer before you do a nightmare derivative. Because the second derivative here really isn't that bad, okay? We would be able to do the chain, product rule again, chain rule on this part, regular derivative on that part. I don't think it would be that bad. It would be more mess, more insane mess, but it would be pretty doable. Are we following along with this, doing the GCF pieces? Again, whenever you do that product rule, especially when you have things like x, like blah, 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 cubed, blah, 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 power 4, take out as much of those as you can, because the way that the power rule works is you'll have n of those things on this side, and you'll have n plus 1 of those things on that side, because this one degraded once and this one did not degrade at all. So when you take out n of them, it'll only leave 1 behind, and then it's very doable. Okay, that was question number 1. Question number 2. What do we think about y equals fraction sine of 3x over cosine of x squared? Well, this one is going to be quotient rule. We got two things stacked on top of each other. This is sine of another function, 3x, so that's going to need a chain rule, and this down here is also going to need a chain rule whenever we do the actual derivative of it. So doing our quotient rule, Mr. Music Theory here from my last class, I remember, low, 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 D high, minus high, D low. Anytime we hit with that D low or D high, we're going to have to make sure we use the chain rule. So dy dx, low, low, all right, that's cosine of x squared. And then onto the top, another low, just a regular low, no derivatives yet. Low, low, low. Here comes our first d high, which is the derivative of the high function, which is going to be cosine of 3x, and eject a little 3, because that's the derivative of the inside using our new chain rule. Low, 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 d high, looks good. Minus, again, lock in on that minus always. High, it's easy, sine of 3x. D low, and the derivative of the low function is going to be negative sine of x squared, also 2x. Now, for quotient rule, we can a lot of times attack it with the same strategy as product rule. Look at that numerator. Maybe we have some GCF, and particularly if we are able to GCF this bottom piece, then when we GCF something that was the same as the bottom, we could eliminate maybe part of the bottom or all of the bottom. And so in particular, I want to look at these two pieces and think, do they both have cosine of x squareds? For example, this first left piece has cosine of x squared. If I can find that over here, they both have it, everybody has it, we can cross them out. But over here, I do not see any cosine of x squared. So I'm not thinking that we're gonna be doing any real big brain simplifications. I think we just need to do a little bit of tidying up, you know, like we have this negative sign and this negative sign. That should probably be a plus sign. Maybe do a little bit of ordering, like this 3 probably can just stick on the front and be a coefficient. But other than that, we're not thinking real big brain on simplifying. So just a little bit of reordering is mostly what we're gonna be doing. The bottom, cosine of x squared, I think that's just gonna stay where it's at. I'm not worried about that. The first piece, again, to reorder it, I probably would just put the 3 out front. 3 cosine of x squared, cosine of 3x. Not too worried about messing with those. And on the second half, I know I have negative sine 3x, negative sine x squared, and a 2x. So I'm probably putting those 2 negatives into a plus. I'm probably bringing this 2x to the front and making it, you know, just a little bit nicer that way. So plus 2x, and then my sine 3x and my sine x squared. And that's that. I'm not gonna really try to push this any further. I'm not gonna try to make this any prettier. It's just how it's gonna go. Question on this one. All right, we're gonna do 2 more questions, and these 2 questions are gonna be shorter than the last ones that we've done. These 2 questions are going to incorporate our memorized derivatives, which was something we were supposed to do today. It was another little memory quiz. We'll talk after if we feel like we want to do it. So let's say I ask you d dx of ln of 5x cubed plus 2x squared. So if I write it like this, again, something we already talked about, but I do want to make sure I go over it. Normally we see dy dx, which means this is the derivative. But if we instead see just d dx of the function, that means find the derivative. It's just saying do the derivative, because the y is actually this part. So anyways, this just means find the derivative of that. We have natural log, and we hate natural log. Oh, natural log's so hard. But actually, what is our memorized derivative? Y equals ln x, y prime is equal to 1 over x. That's actually a very, very easy derivative. Derivatives of ln is really, when I used to teach regular calculus or AP calculus, I could kind of tell relatively early on in the year, like, you're going to have a hard time with derivatives if you struggle with ln, because ln should be super easy. It just put the x on the bottom. So what we're going to do for this, the dy dx for this function, is we need to put this in the bottom. Pretty much as simple as that. All of this stuff, 5x cubed plus 2x squared. And that is the derivative of ln. That's the derivative of the natural log, is put the x on the bottom, done. But whenever we're doing chain rule, we also have to eject the derivative. And so if we eject the derivative, 15x squared plus 4x. Again, that's not very hard either. And what we're left with here, the way this really works when you do the derivative of natural log is the derivative that gets ejected just ends up on top, because there was only a 1 there before. So now, nice, this goes up there. As far as simplifying this goes, for this particular question, we could do a little bit of simplifying, because every single thing has an x, and so we could do a GCF of an x, look to eliminate those. We could. Now, if this original question had a, oh, don't do that. If this original question had a a +1 here, now we can't do anything because now they don't all have x's. Now we can't do a GCF. Now we're stuck. So most of the time that you do these questions, you're not really left with anything to do. However, it does kind of show us that today, when we're doing all of these, it's really a lot of times looking for GCFs of the big messes. The tops and the bottoms, do they have GCF? The left and the right, do they have GCF? So for this question, sure, let's do it. On the top, that would be x times 15x plus 4. On the bottom, I could take out x squared even. I'm probably just going to take out 1x. Because I think it'll look nice when I just cross these out and have 15x plus 4 over 5x squared plus 2x. I think that looks pretty nice. Nothing really else to do there. That's that. Derivative of natural logs, we like them. We like them. We can do them in our head, put the original on the bottom, done. Chain rule, chop it up top, done. Last question we're going to do. Natural logs, we like natural logs, but everybody's favorite is e to the x. I'm not sure why we've gone with w's, but whatever. We got w's, I guess. A function that is w comma y, I suppose. Strange. Now this looks crazy. Probably never seen a function that looks like this. An e with an exponent of a ton of a string, really a polynomial up there. It looks ridiculous. But everybody loves e to the x. E to the x, when you take its derivative, you don't do anything. So when we go to do this question, and we go to do dy dx, it's going to be e to the w power 4 minus 3w squared plus 9. You don't do anything to the derivative. But this is not the super simple e to the x function. This is e to the something function, and that is the function within a function. This up here is our h. And so when we eject that chain rule derivative, it's going to come just down into the regular world. It's not an exponent anymore. It's just multiplied on the end of the function. So it comes down a level, and it would be 4w cubed minus 6w. And that's it. So I like to think of e to the x as almost like a generator, right? It like spawns the derivative, because we could take the second derivative of this as well, and if we did the second derivative of this, the second derivative, which notationally we haven't quite talked about how that would look, so let's just go switch back to our y squared, or y double prime. Now this looks like product rule, this piece and that piece. And so if we're going to do the product rule, we need to do the derivative of the first one, which is e to the w power 4 minus 3w squared plus 9. When we take that derivative, it's going to eject out a derivative, which is going to be 4w, here we go, 4w cubed minus 6w. And that's going to be multiplied by this, which was already there, the same thing it had already ejected last time. So I'm just going to put a squared on this, because the one that came out this time is the same as the one that came out last time. And then product rule. So we need to leave this one alone. And then take the derivative of the second piece, which would be 12w squared minus 6. That's really not all that bad for the second derivative of a chain rule. And as far as simplifying these e to the x's, sometimes, you could maybe simplify it by, ordering this a little bit nicer. A lot of times people like e to go second. But that's, I wouldn't even worry about writing that down on your paper. Like, that's not too big of a deal. As far as simplifying EDX goes, you're not really going to be able to do any real meaningful chopping stuff around or anything. All right, now that we've finished chain rule, we've done power rule, product rule, quotient rule, chain rule, and we've memorized 14 different derivatives. Next time I see you, we'll take a quiz on all these things. Remember, there are easy questions. If you go back to the power rule, those we should be doing them in our head pretty much. But don't expect it to be like 10 very easy power rule questions and then one chain rule question, right? Obviously, it's IB. We've learned all that stuff. So the majority of the questions we're going to do are going to be with probably incorporating at least product or quotient or chain or two of those three. We all got hundreds on our derivative quiz, our memorized derivative quiz. At the same time, if we do it again and you get another 100, it'll be a nice little grade pattern. So why don't we do another one? Is that cool?